In this video lecture, we're going to be solving a linear programming problem. So this question requires us to maximize p equals to 3x plus y. P equals to 3x plus y is a linear function in variables x and y. And whenever you're given a linear programming problem in this form, this linear function is called the objective function, right? So we are maximizing the objective function subject to the following four linear constraints. So these linear constraints, as you can see, are given to you in the form of linear inequalities. Observe the last two linear constraints. These two linear constraints or linear inequalities are called non-negativity conditions. Right, so it's telling you that x is greater than equal to 0 and y is greater than equal to 0. So essentially you are not allowed, well, x and y are not allowed to take on negative values. And when you then sketch this in the Cartesian plane, all it amounts to saying is that you are only working in the first quadrant, because x is only allowed to take on positive values and y is only allowed to take on positive values as well. So I've got our positive x-axis and our positive y-axis. Now there is a procedure that you can follow when you are solving a linear programming problem. The first step, step 1, is to draw or sketch the linear inequalities on the same set of axes. Right, so since the non-negativity conditions are already taken care of, it means that we only have these two linear inequalities, linear inequality 1 and 2, that remains to be sketched on the same set of axes. So we will draw linear inequalities 1 and 2 on the same set of axes. Right, so essentially what do we do? Right, so remember, these linear inequalities are less than equal to. So that means we're going to use a solid line. That's what's required, a solid line. If it was a strict inequality, if it was strictly less than, then we would use a dotted line. So make sure you understand the difference when you are sketching. Right, so the first thing we would do is draw, with the use of a dotted line, we will draw 2x plus y equals to 8. Right, so this is a straight line, and the easiest thing to do when you're sketching is to quickly find out what is the x-intercept and what is the y-intercept for this line. Right, so if you're finding the x-intercept, you are substituting in y equals to 0. So if I substitute in y equals to 0, y disappears from that equation, and I have that 2x equals to 8, which means that x equals to 4. So the x-intercept is the coordinate 4, 0. If I want the y-intercept, it means I'm substituting in x equals to 0. So that means the term 2x disappears and I'm left with y equals to 8. So I have a coordinate 0, 8. So I know that this straight line can now be drawn with these two pairs of coordinates. So I've got 4, 0. So let me just draw a dot to denote it, and 0, 8. There's the dot to denote that. And I'm now going to draw a solid line to denote this. So let me join those 2 points by a solid line. Right, going back to the inequality 2x plus y less than equal to 8. That means that I need to shade below the solid line. So that's what I'm doing now. So after shading, it means that we have now taken care of the procedure to sketch inequality 1. Let's now sketch inequality 2. So with a solid line, we now draw 2x plus 3y equals to 12. Again, I would recommend the same procedure. Find the x-intercept and find the y-intercept. Right, so with the x-intercept, remember we are substituting in y equals to 0. So that term disappears and I'm left with 2x equals to 12, which means x equals to 6. When I'm finding the y-intercept, I'm then substituting in x equals to 0. And if I substitute in x equals to 0, the first term disappears and 3y equals to 12, meaning that y equals to 4. So I now have the two coordinates. Let me now draw this on the Cartesian plane, 6, 0. Here's the dot for that. And 0, 4. Right, so again we are using a solid line to join these 2 points. So a solid line. And now returning to its inequality form, 2x plus 3y less than equal to 12. So I now need to shade below the line. Right, so let me shade below. Right, and that's done. So step 1 complete. Step 2, we now need to shade the feasible region. Right, what is the feasible region? The feasible region in this problem is the set of solutions obtained by sketching our 2 linear inequalities, and this is found by looking at where the shaded regions overlap. Where do they overlap? So we're looking for where the black lines and the red lines intersected, and here is the region that they are overlapping. So I'm outlining this in green, and I'm now going to shade the entire region. Right, so just to do this very quickly, but to stick between the lines so that I shade the correct region. Right, so here we go. The feasible region starts from that point, follows along the line, stops at this point, follows along the next red line to the x-axis, and is bounded by everything. So it's everything above the x-axis and everything to the right of the y-axis. Right, so this is our feasible region. So once we've shaded this feasible region, what is step 3? Step 3 is to find the corner points of the feasible region. The corner points are points on the feasible region, but are obtained by looking at where the lines intersect. So where do the lines intersect? So observe, we have the axes intersecting here at the origin. We then have the lines intersecting here at our coordinate 4, 0. We then have 2 lines intersecting here at that coordinate, and we then have lines intersecting at the coordinate 0, 4. So we have 4 corner points. There are 4 corner points on the feasible region. Right, so what I'm going to do now, whenever you find your corner points on your feasible region, you need to label them. Right, so I'm going to label this A, B, C, and D. Right, so A, B, C, D. What are the coordinates? So we now need to write down the coordinate descriptions. A is the origin, so it's just 0, 0. B is the coordinate. This can easily be read off, so this is 4, 0. C at this point to me is unknown, and D can be easily read off. It's the coordinate 0, 4. So we now need to find C. Now observe that C is the point of intersection of the lines, because we drew this straight line and we drew that straight line, so it's given by the lines 2x plus y equals 8 and 2x plus 3y equals to 12. Right, so that is it. So we can now rewrite this equation as y equals to 8 minus 2x, and then we could then substitute it into the second and solve. Right, so substituting in there, this implies that we have that 2x plus 3y, but y is 8 minus 2x equals to 12. Right, so I've taken this and substituted it in there. Let's now simplify. I have 2x plus 3 times 8, which is 24, plus 3 times minus 2x, which is minus 6x, equals to 12. Simplifying again, 2x minus 6x is minus 4x. Taking the constants onto the right hand side, I get 12 minus 24, which is minus 12. So minus 4x equals minus 12 implies that x equals to 3. So I have the coordinate for x. X is 3. Let's now find out what y is. So y equals to 8 minus 2x. So it's 8 minus, substituting in x equals to 3, it's 8 minus 2 times 3, which is 2. So therefore C has the coordinate 3, 2. So step 3 is now complete because I have found the coordinates for each of the corner points. Right, so I'll just put this on here, 3, 2. Right, step 4 is to either maximize or minimize your objective function. We need to maximize, so we now want to maximize P. Now the procedure that you then follow is you take each of your corner points A, B, C, and D and substitute it into the objective function and get out the answer, and then pick the maximum value. So let's do that. So we have coordinate A, which is 0, 0. We have coordinate B, which is 4, 0. We have C, which we just found, which is 3 and 2. And we have D, which is 0, 4. Alright, so I'm now going to substitute it into P. So I'm substituting in 0, 0. So that means it's 3 times 0 plus y equals to 0, giving me 0. Let's now work with coordinate B. So I'm now substituting in 4 and 0. So it's 3 times 4 plus y equals to 0, giving me 12. Let's now work with coordinate C. So substituting it in there, P of 3, 2. This is 3 times 3 plus 2, which gives me a value of 11. And finally D. So I'm now substituting in 0, 4 into our objective function. So this is 3 times 0 plus 4, giving me a value of 4. Right, so we've got out all of the final answers. The thing to do now is to pick the maximum and observe that amongst these 4 answers, 12 is the maximum. So that means the maximum value of our objective function P is 12, and this occurs at the coordinate B, and that is how you solve a linear programming problem.